Okay, but in fact, in practice, they are not really independent. But now we assume that they are independent. Then to make it for convenience, we assume that they are independent. Then we get 115 for the valence of Ti. What you want to do is the average number of hours that these people what the two events, what all the events. So T is T1 plus T140 divided by 140. Do you understand that? Is that clear? And then you can check to see that the mean of T is the same as the mean of the Ti. So it is 70. All right, and the valence of T, what is that? What is the valence of T? The valence of T is the valence of is 100. The valence of Ti 115 divided by the number of observations. Okay, so it should be 140 here. Do you understand what I'm saying? That's all clear. Okay, and because in this case n is 140, which is quite big, so I may say that T is the average value, T minus the mean 70 divided by the standard deviation, the square root of 115 divided by 140. Okay, that approximately follows the standard norm distribution. All right. Then and if you want to find for the second question, you want to find the probability that T is between 68 and 72. 72.5. Then you come up with the probability that T minus 70 divided by the square root of 115 over 140, and this becomes minus 2 more than the square root of 115 over 140 less than 2.5 divided by the square root of 114 over 140. Okay, and this is, let's say this is Z. Then you get the probability that Z between the two values, and then you can use the calculator to compute the integral. Okay, questions? Hello, is that all clear? Is this okay, everybody? Is this okay? Good. So you have to be careful with the calculations, all right? And be careful. This is the average value. Sometimes it is a sum. It is a sum. Then it is something different. You have to be careful with that. Okay, let's continue with the next example. Now, please have a look at the following problem and tell me your answer. Please think about that for 1 or 2 minutes and tell me what you can get with it. The time between calls to a plumbing supply business is distributed with a mean time between calls of 15 minutes. What is the probability that at least one call arrives within a 10-minute interval? What is the probability that the first call arrives within 5 or 10 minutes of after opening? What is the standard deviation of the time between calls? Then determine the length of an interval of time such that the probability of at least one call in the interval is 90%. Okay. Please think about that for a minute and type in the answer. Oh, yes, of course. I forgot to record the meeting. Thanks. Please think about that for a minute. Did you get the answer? Did you get that? Did you get the answer? Okay, seems like you got the answer, right? Okay, let's see. Now suppose that x is the time between calls, that is x, okay? Then x follows an exponential distribution with the parameter lambda. the mean of x is 1 over lambda, and we know that the mean time is 15 minutes. So it is 15. Therefore, lambda is 1 over 15. All right. Now we are ready to compute the probability that at least one call arrives within a 10 minutes interval. So you want to find the probability that x is less than 10 minutes. Okay. And that would be that would be 1 minus the cumulative distribution function is 1 minus a minus lambda u. Remember that? I use that expression, so I get 1 minus a to the power minus 10 over lambda over 15, because lambda is 1 over 15. Question B, you want to find the probability that the first calls arrive within 5 and 10 minutes after opening. So x is between 5 and 10, correct? Okay, so you come up with the probability that x is less than 10 minus the probability that x is less than 15, less than 5. So you get 1 minus a to the power 10 over 15, okay, minus 1 minus e to the power minus 5 over 15, okay? So you come up with e minus 1/3 minus e to the power 2/3. Do you understand? Is that clear? Okay. Question C. You want to find the standard deviation of the time between calls. That is the standard deviation of x. So you get 1 over lambda, and you get 15. Same thing. Question D. You want to determine the length of an interval of time such that the probability of at least one call in the interval is 90%. So you want to find the value u, the length is u. You want to find the length, the value u such that the probability that x is less than u equals 90%, right? So it's just like you want to find the point u. This is the length, right? This is 0. The length is u, such that the probability that at least one call in the interval this interval is 90%. You have at least one call. It means that the time between the calls, or let's say the time from now until the first call, is less than q, and then you have this one, and this becomes 1 minus is minus lambda u, so you get u over 15, and then you can say that e to the power minus u over 15 equals 0.1, and then u becomes 15 times the minus 15 times the logarithm of 0.1. Do you understand, everybody? That's all clear? Is it okay? Or let's say 15 times the logarithm of 10. Make sense? Everybody, that's all clear? May I move on? May I move on, everybody? Okay, let's consider the next example. Let's try this problem. Do you get the answer? Okay, we all knew that x plus y follows a normal distribution, and the difference also follows a normal distribution. It is remaining to find the mean of x plus 2y. What is that? The mean of x is 1, the mean of y is 2, the valence of x is 3, the valence of y is 4. So this becomes the mean of x plus 2 times the mean of y. And then you get 1 plus 2 times 2, and you get 5. For the valence of x plus 2y, you get the valence of x plus 4 times the valence of y. Okay, and that is 3 plus 4 times 4, and you get 19. So x plus 2y follows a normal distribution with the mean 5, and the valence is 19. That's okay? It is okay? All right, next, we want to find the mean of x minus 2y. That is the mean of x minus 2 times the mean of y. The mean of x is 1 minus 2 times 2, and you get minus 3. For the variance, you get x minus 2y you have to be careful. It must be the values x plus, okay, 4 times the values of y. And you get 3, wait a minute, 3, yes, plus 4 times 4, it is still 19. And then x minus 2y follows an harmonic distribution minus 3, 19. Do you understand? Is this all clear? Do you understand, everybody? Okay, let's try the next problem. Okay. So you can find, you can solve question A, B, and then C. You got the answer? Okay, let's give it a try. For the first question A, you want to deal with the weight of a shoe. So suppose that X is the weight of a shoe. Then you want to find, and then X follows a normal distribution with a mean 12 and the standard deviation 0.5. Okay. And then you want to find the probability that the weight is more than 13. So X is more than 13. And then you get the probability that X, well, you can say that X minus 12 over 0.5 follow the standard normal distribution, right? Then X minus 12 over 0.5 more than is more than 13 minus 12 over 0.5. So you get the probability that what is that? You get z. This is going to be z. So you get z is more than 2, I think, right? So you get the integral from 2 to infinity 1 over square root of 2 pi e minus u squared over 2 du. If that's clear. Is that okay? All right, that is the first question. It is very straightforward. Question A. How about B? For B, what must the standard deviation of weight be in order for the committee to state that 99% of its shoes weighs less than 13 ounces? So you want to know if suppose that X follows a normal distribution with a mean 12 and the standard deviation S. So you want to find the value as such that the probability that X is less than, right? So actually less than 13, that should be 0.99, let me see, 99, right? And then you come up with the probability that X minus 12 over S less than 13 minus 12 over S. You know, X minus 12 over S, that is Z, that follow the standard normal distribution. Then you get the probability that Z is less than 1 over S, okay? On the other hand, you can use the table to see that this is Z less than 2.33. So the answer is 1 over S is 2.33, or let's say S is 1 over 2.33. Do you understand? It is okay? It is all right? Okay, concerning question C, it seems that you don't agree, you don't have an agreement here, right? How can we solve the problem? Question C. Question C, okay. There are 25 shoes. Suppose that X1, X2, and Xn, X25, they are the weight of the shoes. Then you can see that they follow an distribution with the mean. Was that 12? The variance is 0.5 square. Okay. Then you want to deal with the average weight. So let's say H bar is X1 plus X25 over 25. We knew that the mean of Xi is 12. The variance of Xi is 0.5, and the standard deviation of Xi is the square is 0.5. Now we knew that the mean of the average value is 12, and the standard deviation of H bar is 0.5 divided by the square root of n, which is 25 here. So you get 0.1. It is easy to see that H bar minus 12 divided by the standard deviation 0.1, that follow the standard normal distribution. All right. And denote this one by Z. Then now I want to find the probability that the average value is less than 13. X bar is less than 13. That would be the probability that X bar minus 12 over 0.1 less than 13 minus 12 over 0.1. And then you get the probability that Z is less than 10. So I get the integral from minus infinity to 10, 1 over the square root of 2 pi e minus u squared over 2 du. And that is approximately 1. Do you understand, everybody? That's all clear? You have to be careful. The probability cannot be 11. It has to be between 0 and 1, right? Do you understand, Everybody, that's all clear? Any questions so far? We don't use T. We don't use T. The reason is that we don't use T. The reason is that we don't use T. The reason is that we get, let's say, X bar minus M over S over the square root of N. Then that follows the T distribution if Xi follow a normal distribution, right? Understand? Now, what we get is that X bar minus M over sigma over the square root of N that follow the standard normal distribution. Do you understand? So for effect for the midterm, you don't use T. It is okay. Okay. Let's consider the next example. Do you get all the answer? Okay. Let's see what we can do with this one. In order to find k, you need to find you need to use the equation a1 equals the integral from 0 to 10, right? The function is k minus x over 50 dx. So you get k times x minus x squared over 100 from 0 to 10. And then you get 10 times k minus 100 over 100. So you get 10 times k minus 1. Therefore, k is 0.2. Question B, you want to find the probability of a failure within the first 6 years. It means that the lifetime is less than 6 years, right? So you want to find the probability that x is less than 6. And that is the integral from 0 to 6 k minus x over 50 dx. So you get k times x minus x squared over 100 from 0 to 6. Okay, and then you can get the answer, right? That is easy. Question C, what is the expectation of the lifetime? You want to find the mean of x, and that is the integral from 0 to 6 x times k minus x over 50, where k is 20%, is 0.2, and then you can get the answer. If that's all clear? Is this okay? Understand, everybody? Okay, let's try the next example. Suppose that x and y are independent, and they follow a uniform distribution on the interval 0, 1. Compute the mean of x plus y and the variance of 3x. Find the conditional probability that x is between 0.3 and 0.7, given that y is more than 0.5. You got it? Okay, let's go over the problem. In this case, you get x and y follows a uniform distribution, right? So then you get x and y follow a uniform distribution on the interval 0, 1. And then you want to find the mean of x plus y, which is the mean of x plus the mean of y. So it is 0 plus 1 over 2 plus 0 plus 1 over 2, and you get 1. For the values of 3x, you get 9 times the values of x, and that is 9 times 1 minus 0 squared divided by 12, and you get 3/4. Okay, that is question A. For question B, you want to find the conditional probability that x is more than 0.3, less than 0.7, given that x is given that y is more than 0.5. Then because x and y are dependent, you can remove the condition without any problems. You get x is greater than 0.3, less than 0.7. And then you get the integral from 0.3 to 0.7. And the rest of the function f of u in this case is 1, right? Then you get 40% for that probability. Do you understand, everybody? That's all clear? Okay. So in this problem, the x and y are dependent, then you can remove the condition without any problem. However, if the two events are not independent, or the two random variables are not independent, then you cannot do it that way. Let's consider the following example. In this case, x is a random variable with the rest function. Now you want to determine the constant c, the mean of x, and the conditional probability that x is more than 1/2, given that x is positive. Can you do that? Get the answer? Okay, now you want to determine the value of C. In order to do that, let's say 1 is the integral from, what happened? The integral from -2 to 2 f of x dx. And then you get the integral from -2 to 0 minus c x dx plus the integral from 0 to 2 c x dx. Okay, from here you can get the value of c. For the mean of x, what do you get? The mean of x is the average, is the integral from -2 to 2 x f of x dx. And then you get the integral from -2 to 0 x times minus c x squared dx plus the integral from 0 to 2 cx squared dx. Okay. For the conditional probability, you need to find the probability that x is more than 1/2, given that x is positive, and that is the John probability x is more than 1/2, and x is positive over the probability that x is positive. And that is the probability that x is more than 1/2 divided by the probability that x is positive. Do you understand? And then you get the integral from from 1/2 to 2 c x squared dx over the integral from 0 to 2 c x squared dx. Do you understand? Is that all clear? Okay. That's all clear, everybody? Is this okay? Oh, I think that is the typo. It's just cx. Sorry, not cx squared. We only have cx with the with the mean value. So you have x times f of x. No, you don't have it. Just cx. Thanks. This okay? Thank you. Just cx. Thanks. All right. That is question. That is the question in which you need to deal with the conditional probability, right? Now let's try the next example. In this case, you need to deal with random vectors. Okay. Perhaps let's have a break of about 10 minutes. Okay, and then we can continue with this problem. In the meantime, you can think about this problem, question 13. Okay. Hello, can you hear me, everybody? Hello? Okay. Can you log in the BK Learning for the video? Please have a look at that and tell me if you can see the practice test for the midterm exam. The video class, okay? Please look for this. Probability and statistic video. Can you find it? Okay. And can you find this one? Can you find? Do you see this one? The practice test for midterm exam. Can you see it? Do you see it? The practice test for the midterm exam. This is the one. Okay. So do not do it today. I'm sorry. Do not do it now. You can try the problem later. All right. So for now, I just want to continue with the lecture. All right. You can try the practice later. Okay. May I move on, everybody? And by the way, for question 13, can you solve the problem? Do you have any? Haven't got any solution. Look, please do not try the problem. The quiz right now. That quiz will not be counted. And I give you 20 times to try to practice on the test. Okay. Question 13. Do you have any solution? Come on. Okay, let's give it a try. Now, let's have a look at the table here. You get the x and y. X could be 1 or 0, 1 or 2. Y could be 0 or 1. And then you get C, 2C, 2C, and 3C. Okay? And the total sum is 8C. That might be 1, so C is 1 over 8. Do you understand? Okay. Then you get, I can rewrite this table as follows. You get x and y, 1 and 2, 0 and 1, 1 over 8, 2 over 8, 2 over 8, 3 over 8. Okay. And then you get the values 3 over 8, 5 over 8, 3 over 8, 5 over 8, and 1. Okay. All right, now you want to find the mean of x. The mean of x is the mean of x is 1 times the probability that x equals 1 plus 2 probability that x equals 2. And then you get 1 times. You have a look at the marginal distribution, 3 over 8 and 5 over 8 here. You should get 3 over 8 plus 2 times 5 over 8, and it is 13 over 8. Okay. If you want to find the variance of x, you need to find the second moment, which is 1 square times 3 over 8 plus 2 square, quite similar to this sum, 5 over 8. And then you get 23 over 8. Okay. Now we want to find the conditional probability that y is 1 given x equals 2. That is the joint probability y equals 1 and x is 2 over the probability that x equals 2. Y is 1, x is 2. This is the value, 3 over 8. So you get 3 over 8. And the denominator is the probability that x equals 2, which is 5 over 8. And then you get 3/5. Okay, do you understand? That is question B. Concerning question C, you want to find the mean value of x times y. Okay, x could be 1 or 2, y could be 0 or 1, then x times y could be 1 times 0, 1 times 2, 2 times 1, 2 times 0, and 2 times 1. Then I get the mean value of x times y is simply 1 times 0 times probability that x equals 1 and y equals 0 plus 1 times 2 probability that x equals 1, y is 2 plus 2 times 0 probability that x equals 2, y is 0, and probability, 2 times 1 probability that x equals 2 and y is 1. This is 0. This is 0 as well. So you only need to compute the other two terms. then it is 2 times the probability that x equals 1. Y is 2. Wait a minute, did I miss something? There should be 1 here. It should be 2, right? It should be 1, I think. Because it is 1, 0, or 1, 1, 2, 0 to 1. Yeah. Then I get the value 1 times the probability that x equals 1, y equals 1. X is 1, y is 1. You get 2, 8. 2, 8. So you get 2 over 8 plus 2 times, this is going to be 3 over 8. And the final answer is 1. Is that all clear, everybody? Is that all right? That should be okay, right? Okay. Okay. Now let's move on with another problem. This problem is quite simple, so I will skip this one. But I still want to put it here for just in case you know how to solve the problem. So for this, you need to determine the value of C. All right, and after that, you can find the values of x and the expected value of y. Okay, so may I skip the problem? Is this okay? Is this okay? May I skip it? Okay, you know how to solve the problem. All right. I think that's all for the review. Now I want to give you a further discussion about the hypothesis testing. Okay. Hello. Is there any noise? Can you hear me clearly? Okay. Is there any noise that you cannot, that makes you uncomfortable? It is okay, everybody? Okay, great. All right. On the slide, I'm showing you the outline of what we studied in the chapter of hypothesis testing. Correct. Now I want to give you further discussion about this. Okay. So please tell me, what is the test I should use in this case? This is the approximate z-test. In this case, you call it a t-test. In this case, you call it the exact t-test, z-test. Okay, back to this. What is the test I should use in this case? Should it be z-test or t-test? Should it be z-test or t-test? Do you remember? We already did this problem last time. Z-test, that's true. That is what we study. Now, let's consider a quite similar problem. I should change it a little bit. In the first case, I showed you the probability, the population. Let me see, the population variance, right? The population standard deviation 0.5 in the first case. But now I give you another value, an extra number, which is 0.7 for the sample standard deviation. Okay. Can I use z-test in this case? Or let's say, can I use t-test in this case as well? Can you tell me? Can I use z-test? Can I use z-test? No. Okay. Yes, you can, of course, because it is similar to the first problem, exactly the same. In fact, in the first case, you have you use the sample mean, you use the population standard deviation, you have the normality, the number distribution, the same. That's why you can use z-test. That is for sure. My question is, can I use t-test in this case? Can I use t-test? Can I? Yes, you can use t-test because you can go back to the outline I gave you here. The distribution is still normal, right? And you use the S square, then it is the t distribution. That's true. Okay. So you can use both of them. But then, which one should I use? Should I use z-test or t-test? Which one? Z-test. Well, in fact, Z-test or T-test, in fact, you should use Z-test. The reason is that even though you can use both of them and they are exact tests, you should use the Z-test because Z-test, the Z-test has greater power. It gives you more chance to reject the null hypothesis when it is false. So it has the higher power of test. That's why the Z-test is the better method. Okay, do you understand, everybody? Is that clear? Is that clear? Is that all clear, everybody? Okay. Okay, let's consider the next example. This is the one that we already did. Do you remember the test we used last time? Which one? Is that a Z-test or T-test? Yes, that's true. Last time we used T-test for this problem. That is correct. All right. Now I changed the question a little bit. I changed it a little bit. And this is the one we got. Then tell me if it is a T-test or a Z-test. Can I use Z-test in this case? Then can I do T-test as well? Can I do T-test as well? Which one? Can I use T-test in this case? Can I use T-test in this case? Hello? Can I use T-test for this? Yes, that's true. Because it is quite the same, right? In the first case, you get 20. In the second case, you get 40. It's just the same, quite the same. So you can use T-test, that's true. Yes? Can I use Z-test for this? you can also use z-test, okay? But is that the first z-test or the second z-test? This is a z-test, this is also a z-test. Is it the first z-test or the second z-test? Which one? The first or the second? The second z-test, that is true, completely correct. So now we have the two tests here. Which one should I use? Should I use t-test or z-test? Z-test, why is that? Well, in fact, we should use t-test in this case because the second z-test is an approach test. It is not the exact test. The first two tests are the exact tests. Okay, the second z-test is the approximate test. That's why you should use t-test instead of z-test. Do you understand? Okay, good. One more thing. Okay, now we want to perform the test on the alternative hypothesis that and the mean value is greater than 1. Okay. Now you have a look at these two data sets, X and Y. Are they the same or different in your opinion? Are they the same or different? Are they similar to each other? Do you think that they are similar to each other or not? No, they're not similar to each other. Why is that? What do you think? What's the point? How different? How different? Why do you think that they are different? Oh, just that? Just between the highest and lowest? Um, well, they are different, of course. If you just look at the difference between the aggressive value and the least value, then they are different, of course. But I don't think this is the problem, right? on when you perform the test, it could be any number, correct? Right? It could be any number. Well, now here is the actual difference between them. If you draw the histogram of the two data sets, this is what you can get. Okay, now do you see that they are different in this case? Can you see the difference here? How different? How different? Well, that's true. So you can say that the first one is quite symmetric, and you may have a normal distribution here. It has a bell shape, but for the second case, for the second graph, you get a skewed distribution, heavily skewed distribution. So it is not normal, obviously. For this, you may have a normal distribution, and in order to test the hypothesis for the first case, you can use t-test. Okay, you can use t-test. How about the second case? Which test should I use? It is a t-test or z-test? Is this a z-test or t-test? Can you tell me? Should it be z-test or t-test for the second case? Which one? Why do you think it is z-test? Why do you think so? Why do you think that it is z-test? Well, you cannot use t, but what do you think that you can use z? You cannot use t, it doesn't mean that you can use z, right? You don't have a car, it doesn't mean that you have a plane, right? So in fact, in this case, you cannot use z-test. You cannot use t-test either. You cannot use any of them. Okay, you cannot use z-test because there are only you cannot use the first z-test because you don't have a normal distribution. Okay, so you cannot use the first z-test. You cannot use this t-test because it is not normal. You cannot use the second z-test because the sample size is not large enough. Okay, so in the second case, with this data set, unfortunately, you cannot do it. Okay, you cannot use the method we just used. All right. Do you understand? That's all clear? You need to use some other methods, but it is not what we learn in the class. Make sense? Is that all clear? All right. Okay, I think that's enough for today. Do you have any questions so far? Any questions? Oh, which day for the midterm exam? Which day? Okay, the 7th. Concerning the software, thank you. It is Sunday. Okay, so please be very prepared for the midterm. You may want to practice on. There are several quizzes that you can try. Okay. The deadline for the practice, there is no deadline for that. I will make it available until Saturday night. Okay. And so before the midnight Saturday night, I will close it. All right, because in fact, no. In fact, I think you need to take a good sleep. So yeah, in the morning, you just take a break. Just have a review. Do not do the quiz during that time. I don't recommend that. Okay. Okay, so I will close it before the midnight. Right. Okay. I don't want you to stay up late. So, okay. Any questions so far? Oh, by the way, it is an overview exam. I think I forgot to mention that in the. Oh yes, I think I did mention that. Let's check. Okay, I will mention that. So you are allowed to use any hard copy of the any materials you like, but they must be in hard copy. They must be hard copy. Okay, you are not allowed to use any soft copy. All right. Any questions so far, everybody? Everybody, is that okay? Good. Practice quiz 2 and quiz 3. Oh, in fact, quiz 1 is I accumulate all the quizzes 1, 2, and 3 all together into a single quiz. Can you recognize that? But I try to group some questions. That's why every time if you take the quiz the second time, you may get a different question somehow. All right. So it will make the quiz not that bored. All right. So. All right. Any questions so far, everybody? All right. Okay. Thank you very much. And so we can stop here and see you next time. All right. Goodbye. Oh, do you need to study any classes next week? Just in case, if we can set up another meeting next week. Do you have any class next week, everybody? Okay, I see. That makes sense. So some students will need to take classes next week. Some students. Okay, that's the problem. Yeah, that's the problem. So perhaps we may, there will be some a class, maybe a TA class or makeup class during the weekend. We cannot do it during weekdays, but maybe during the weekend. I will see if we can do it. All right. Okay. Oh, and by the way, please check the weekend learning regularly for the announcements, because I might give you some quizzes just to remind you what you need to learn. Otherwise, you will forget everything when you come back. All right. Thank you, and see you next time. Goodbye.